If you've ever tried to do anything with linear motion from scratch, you know how frustrating it can be. There are hundreds of vendors with hundreds of parts, page after page of tables and catalogs. There are countless decisions to be made. Does this bearing rod go with these bearings? Which mounting hardware do I use? Is this the right timing belt for the setup? How do I mount the motor? Do they even sell anything a hobbyist can afford? And on it goes. If you'd like to see an affordable solution that provides all the key elements to allow you to quickly build a complete linear axis of just about any length you choose, please watch my solution that I call InnerDrive. Hi, my name is Craig Kessler, and welcome to my first Kickstarter project. I call it InnerDrive, a low-cost, modular, linear motion system for makers. It consists of off-the-shelf 20mm extrusion, an MXL timing belt, and custom Delrin components, along with a special laser cut or 3D printed MXL belt clamp. Before I get into the details, let's go back in time and see how this project started. About 5 years ago, I drew this concept on my kid's chalkboard. I've been dabbling with benchtop CNC machines and had grown frustrated with the lack of simple, inexpensive linear motion components. At the time, I had no idea how to build it. All I knew was that I wanted a simple, scalable, linear axis that took advantage of an aluminum extrusion's channels to hide and protect the drive belt. I also wanted an easy way to mount a stepper motor. Fortunately, the kids had long since tired of the chalkboard, so the drawing remained. Every time I walked by it, I thought about how much I liked the concept, but my day job kept demanding more and more of my time and energy. Then, late last year, after nearly 25 years of faithful and distinguished service, I was let go from my engineering job at a major automotive electronics company. It was at that point that I decided to see if I could make this linear motion system, that I now call InnerDrive, a reality. After nearly 2.5 months of 3D CAD design and redesign, and dozens of 3D printed and laser cut prototypes, I am now proud to announce that I have succeeded in bringing that idea to life. I now present to you the InnerDrive linear motion system for makers. Before I wrap this up, let me cover some of the unique features of this system. The key feature of this system is the laser cut or 3D printed MXL belt clamp. This allows the drive head assembly to be attached to the belt while keeping the belt inside the extrusion channels. Another feature of the system is the drive head plate. It has been designed so that a piece of 20mm extrusion can be cleanly and flushly mounted to the drive head plate with one hidden bolt and 2 side bolts. This allows a clean mount installation, and this could be another axis, and that axis then would be in the same plane as this axis. So you could have an XY gantry system in a compact form factor. Another feature of the system is the Delrin follower assembly and mounting bracket. Once the extrusion has been cut to length and the MXL timing belt has been cut to length, you can then loosen these bolts, slide this bracket, and apply tension to the belt. It's a very simple belt tensioning system. Another feature of this system are these stub ends. These allow you to mount your axes as a module in between your rail elements. You can loosen these bolts and adjust these stubs to to make up any tolerance difference between your overall axis module and your end mount points. Just imagine what you could build if you had a simple, modular, linear axis kit to start from. And wouldn't you feel great knowing that you were a key part of making this new product available to the maker community? With your pledge of support, we can get the volume needed to have parts professionally manufactured at a reasonable cost. So what are you waiting for? Pledge today. Well, that's about it for the Kickstarter project for my InnerDrive linear motion system. Thank you for your time, and I look forward to your pledge of support. If you find this interesting, please tell your friends. Thank you.